So now let's do number B. We are doing BI now. At what point does this B appear to be differentiable? At what point you can say you can say from -3 up to but not including 0, and then from 0 not including it up to 3. Okay, and so you can say and you can put and say and from 0 in greater than 0 and less than or equal to 3. So we are not including 0. So everything but not including 0. If you wanted to put it in the other notation, which is the interval notation, you can say -3 to 0, including -3 but not including 0. Then we start at 0 but not including it and end at +3. That's the other way to do it if you want. Now, why? Why do we say that? They say at what points does each function appear to be differentiable? So here, it is function. You can say function is the function, or you can say y equal to f of x is continuous at these points and has no sharp corners or cusps. Good. Now let's do part II. Neither continuous but not differentiable. No such point. No such point. Okay. Why? Why is the reason? You can say function has a smooth curve at every continuous interval. Okay, it has a smooth curve at every continuous interval. In other words, there are no sharp corners, or cusps in the continuous region. Okay, in the continuous region, there are no sharp corners or cusps. Then we can now go to part 3, where it is neither continuous nor differentiable. You can say this is at x equal to 0. Okay, y is equal to f of x is not continuous. At this value. This is us writing at this value, because why? At this value, because there is a jump. Okay, there is a jump at this point. At what? At x equal to 0. There is a jump, and therefore it is also not differentiable. It is also not differentiable. This is it, and we'll be done. This is the third one. Now we can do part C, and let's see how it goes. Okay, goodbye. See you in the next one.